Today we will discuss some basic facets on how a population can be regulated. Usually, they can be regulated by two ways. One is known as density-dependent factors, and the second one as density-independent factors. Now, consider the situation where our density-dependent factors, that is, all these factors are very much density-dependent. I mean to say, these factors whose effects on the birth rate or death rate of that organism or the population change as a function of the population density. We can put an example. A population of horses can increase exponentially until there is a competitive intraspecific interaction which causes either the birth rate to decrease or the death rate to increase, or there may be a paucity of their nutrients or food, leading to a net decline in the reproductive rate and subsequent decrease in the population density. So either their interspecific interactions, which can decline their density, or their food sources or the resource availability can regulate their density or their number. So in this way, this density dependent factors can regulate the population. There are some other factors, usually known as density independent factors, and these are usually climatic ones, and they can regulate the population by some natural catastrophes like flood, hurricanes, seasonal variation or fluctuation in the weather pattern, and all these things. So the physical environment here play the pivotal role to regulate the population. In some circumstances, a particular environmental condition favors their growth, and in others, they suppress or modulate the population growth in a negative way. Next. Now, in the last class, already we discussed the type of survivorship curves and the growth patterns in population ecology. We all know about the logistic growth and the exponential growth pattern. Now, the population ecologist, depending on the population dynamics and life history, they differentiate two types of strategy. First one, the R strategist or the R selection pattern, and the second one as the K strategist or the K selection pattern. But we must consider the situation that there is no ultimate one. That is, although some organisms which prefer or which establish themselves as a R strategist, they also can show the K selection in some of their life or in situation. But broadly speaking, either they prefer to establish R selection or K selection. Now, for the R selection, when the environment is variable and unpredictable, they mostly try to establish themselves by their high rate of reproduction, and their motility is density independent. They show type 3 survivorship curves. That is, in the survivorship pattern, they show type 3, which is the concave one, and they show a rapid development, high rate of increase, early reproduction, small body size, and in each reproductive episode they produce numerous and many small offsprings. Some of them may continue their life and some can't. Usually we can use the term similparity for the all R strategists, and this similparity actually indicates a single reproductive event, and in each single reproductive event they produce many small offsprings. They have very low social organization, and as they are very low social organization, they have to depend solely on the favorable condition of the environment for their biological activity, for reproduction, and all other purposes. And we can also use them as an opportunistic one. They have a very short lifespan, and obviously there is no parental care. So, in this way, we can categorize the R strategist organisms. They are like algae, bacteria, rodents, some small annual plants, small insects. These are all R strategists. And as I already mentioned, they reproduce and disperse rapidly when they have a favorable condition or when disturbance open up a new habitat or niche, and they usually flourish to a new area which provide a better condition for their establishment. And obviously they show a very early stages of the ecological succession. On the contrary, the case selection species or the organisms which prefer the K strategy, they can develop a predictable and constant environment. Usually they are density dependent, and they usually show type 1 and type 2 survivorship curves. They have a very slow developmental pattern. They have a higher competitive ability. They can cope up with the environment and can modify themselves according to the environmental need. They can produce an early, not early, like the R strategist. Rather, they prefer late reproduction strategy. They have a very larger body size, and in the reproductive event they produce very few organisms which are much bigger but much more efficient to cope up the environment. For them we can use the term interoperous or interoperity. That is, they have very few reproductive events throughout the life. And they have a very high level of social organization. And this pattern and this nature is very suitable for their establishment in that particular environment. They have a very long lifespan, and in this long lifespan they have to interact, they have to understand, they have to modify their all behavior patterns to cope up with the surrounding environment. and they have a very efficient parental care. All higher organisms, mammals, larger plants, human beings, all of this prefer and establish themselves as a care strategist. Thank you.